All right, let's look at the midterm review. So midterm's 50 questions. It's all multiple choice. So for a question like number 2 on the review, it says solve using the quadratic formula. Solve it however you want on the midterm. If it says solve using the quadratic formula and it factors, then just factor it. Or you could even take your answer choices and plug them in and solve. For a question like number 3 for the inequality, here we know that an absolute value is a positive number, so it can never be less than a negative number, so that's why we have no solution here. But if this was something like the absolute value of x minus 7 is less than positive 8, if it's less than, we would split it up into 2. So you could say that x minus 7 is in between negative 8 and positive 8. And then you'd solve, so we'd add 7 to both sides. So this would be negative 1. So x is in between negative 1 and 15. The answer is probably going to be written in interval notation. So this would be from negative 1 to 15. Make sure you pay attention about the parentheses and the brackets. But we know that if this interval notation was an answer choice, it's talking about all of the numbers in between negative 1 and 15. So you could always pick a number in between, plug it in to make sure it makes sense to know if you did it right. So if this was the absolute value of x minus 7 is less than 8, less than, oops, sorry, we just did less than, greater than. Let's say that this was greater. Greater, we split it up into 2. So it'd be x minus 7 is greater than 8, and x minus 7 is less than negative 8. So greater, you split it up into 2 of them. So add 7. X is greater than 15, add 7. X is less than negative 1. So this would be outside. So it'd be from negative infinity to negative 1, and then from 15 to infinity. But again, if you're not sure which way to do it, this way or this way, you're like, oh, I don't remember greater than. Do I split it up into 2? Do I make it one inequality? Thank you. Look at your answer choice and plug it in. These values are different than these values, so one of them will make sense when you plug it back in. So use your answer choices to help you. Let's solve the inequality in number 4. So since it's an x squared and an x, we know we have to factor. So when we factor, we want it to be equal to 0. Here it's an inequality, so we just want 0 on one side. So we're going to subtract 6x and subtract 7 to move it to the other side. So x squared minus 6x minus 7 is greater than 0. Now we can factor. So what are 2 factors of negative 7 that add to negative 6? Negative 7 and 1. So x minus 7 and x plus 1. We'll just say equals 0 for now. Since we have 2 answers, we're going to want to check our answer choice anyways. So we can say x equals 7 and x equals negative 1. So we'd want to put those on a number line. Negative 1 and 7. And then we want to check and see, are we talking about values in between these numbers or outside? So you can plug in something like 0, because that's in between. You can either plug it into the original or plug it into your other one. It doesn't matter. I'd recommend plugging it into the original just in case you made a mistake with your work somewhere. So we have 0 is greater than 7. This is not true, so it's not in between. You can be super, super sure and plug in a number outside just to double check your work, but outside's going to work. So our answer would be from negative infinity to negative 1 and from 7 to infinity. For a question like number 5, you guys know how to find the slope. Put it in slope-intercept form, and that'll give you your slope and your y-intercept. For number 6, it gives us the point in the slope, so we can plug it into point slope form. So make sure you know point slope form. Y minus y1 is equal to m times x minus x1. This is point slope form. Slope intercept form is y equals mx plus b. I think at this point you guys know them both, but just definitely make sure you remember point slope form, because if it gives you a point in the slope, you're going to want to plug it into point slope form, and then you can rearrange it from here. So y minus -5 is equal to 2/3 times x. This would be plus 6. So then you can rearrange your equation. So for number 8, it says find all the real values of x such that f of x equals 0. So here we just set it equal to 0, so we'd have to factor. 2 factors of 36 that add to 15, ignoring the answers that are already there, would be -3 and -12. So x minus 3 and x minus 12, you guys know how to factor, but just don't be confused with how the question asks it. So find the real values of x. You just set it equal to 0. Make sure you look at the question. I know a lot of the recent stuff we did, we set the derivative equal to 0. This is just asking for your function equals 0. So don't overlook the question. Don't make it harder than it needs to be. Finding the zeros is the same thing as solving. You just set it equal to 0. So same thing with number 9. Whenever you have a fraction, when you're finding the zeros, you can just set the numerator equal to 0. If you want to set the whole thing equal to 0, it's the same thing when you cross multiply. It gets rid of the denominator anyways. So 10 minus x squared equals 0. Add x squared, take the square root. What does x equal? Plus or minus square root 10. Perfect. When we find the domain of functions, 2 things we have to keep in mind. If we have a fraction, so if x is in the denominator of a fraction, bless you, our denominator cannot be equal to 0. Also, if we have a square root, whatever's on the inside of our square root, we'd set greater than or equal to 0. And then those 2 combined, if you have a square root in your denominator, you would set whatever's under your square root just greater than 0, because it can't be equal to 0 in the denominator. So these are 3 things you need to keep in mind for domain. So for something like number 10, we would set our denominator not equal to 0 and solve. So y cannot equal -5. So it'd be all real numbers except -5. It might be written in interval notation on the midterm, so it would be from -∞ to -5, and then from -5 to infinity. So these are the same thing. Now, when we're checking the domain, I said if we have a square root, it has to be greater than or equal to 0. This is when you have an even index square root. So square root, 4th root, 6th root, you can't have negatives underneath. If it's the cubed root, you can have negatives. So cubed root, 5th root, any odd index, you can have negatives. So for a question like number 11, this would be all real numbers, because we can have negatives, we can have positives. It doesn't matter what we have under a cubed root, because it's an odd index. So for like number 12, just set the denominator not equal to 0, solve for x. For 13, finding the domain and range. Domain, you go from left to right, so it's all of your x values. Here it implies that the graphs have arrows. So our domain, our graph goes forever in the left direction, forever in the right direction, so it would be from -∞ to +∞. And then our range is the y value. So we start at the bottom, go to the top. So our graph goes down to negative infinity. And then our graph stops here at the y value of 4. And it would be a bracket. So unless it's an open circle, it'll be an explicit open circle. That would be a parenthesis. But here it includes 4, you touch 4, so it would be a bracket. For 14, find the zeros, just set it equal to 0 and solve. So here we'd have to factor. Take out your GCF. Same with 15, to find the zeros, set it equal to 0 and solve. Be careful here. A lot of people on the last quiz or test got confused when they saw a square root. To get rid of a square root, we would square both sides. So it cancels out, so we'd have 6x plus 5 equals 0. And then solve. For 16, we have a combination function. So here we want to find f plus g of t minus 6. So we're going to add our two functions together and then plug in t minus 6 into the x's. So you can either plug it in first and then add them together, or add it and then plug it in. It doesn't matter the order that you do it. I'll add it together, so I'll find f plus g of x first, and then I'll plug it in. So this would be x squared plus x, and then our like terms would be minus 2. Then we would take t minus 6, plug it in. So t minus 6 squared plus t minus 6 minus 2. From here, we'd have to simplify. So t minus 6 squared, FOIL it, t minus 6 times t minus 6. We get t squared minus 12t plus 36 plus t minus 8. Yes.
And the other way of doing it is just plugging in t minus 6 to both and then adding them. But why was it f plus g of x? Why wasn't it, what does that mean? You just added them in the beginning?
So f plus g just tells you need to add your functions together, and then whatever the value is here. So here, typically it would give you like a number, like f plus g of either x, where you just leave x in your answer, or f plus g of 5, and you'd plug 5 into the x's, but here it gives you t minus 6 to plug in. So it's the same concept, it just tries to make it a little bit harder, but just take that, plug it in, and then simplify. So when we simplify and combine our like terms, we'd get t squared minus 11t plus 28. So that would be our answer. So the other way of doing it is you could have plugged in t minus 6 first, so t minus 6 squared plus 1, and then t minus 6 minus 3. Find these two. You could simplify it first and then just add them together. It's probably an equivalent amount of work. I wouldn't say one way is easier than the other. So in 17, it tells us to multiply them. So you can either multiply your two functions together and then plug in -4, or plug in -4 and then multiply your two answers. Here I would probably say plugging in -4 first would be easier, and then multiplying it. That way we don't have to multiply our two polynomials and FOIL. So when we multiply, or when we plug in -4, we would get -4 squared would be 16 times 4 would be 64 plus 1 would be 65. When we plug it into the second one, this would be -4 minus 2. So that would be -6. So then we just multiply 65 times -6. So we could have multiplied them together, FOIL it out, and then plugged in -4. Either way works. Let's do a composition function. So composition functions, the order matters that you plug it in. Always start from the inside. That goes into the other one. So G is on the inside, so we're going to take G and plug it into the X in F. So we have the cubed root When we take g and plug it into x, this would be x cubed plus 8 minus 8. And then simplify. Just be careful simplifying. If you had parentheses with an exponent, you can't just get rid of the parentheses. You can't distribute your exponent. If you have parentheses squared, you'd have to FOIL. If it's cubed, you'd have to multiply it 3 times. So this would be the cubed root. Here we don't have an exponent, so we can just get rid of our parentheses and combine the like terms. 8 minus 8 would cancel. And the cubed root of x cubed would just be x. So that would be our answer. Take the second one. So here g would go into the x and f. For b, f would go into g. So we'd take f and plug it into the x and g. So just make sure you know the difference of what it's asking, which one's going in where. Let's find the inverse function. So for 20. So to find the inverse, switch your x and y and then solve for your new y. So f of x is just a fancy way of saying y. So we're going to make that x, and then x is going to become y. So we have x is equal to 6y plus 1, and we solve for y. So subtract 1 on both sides. X minus 1 is equal to 6y. Divide by 6. So y is equal to x minus 1 over 6. And that's our inverse. Let's look at 22. It says use a graphing utility to graph the quadratic function, identify the vertex, axis of symmetry, and x-intercepts. So you guys can do this however you want. If you want to put it in your graphing calculator, find your vertex, you can do it that way. Make sure you know how to put it, if this was standard form, make sure you know how to put it into vertex form. So you can either complete the square and put it into vertex form that way, or you can use your vertex formula to find the vertex and then plug it into vertex form. So our vertex formula would be negative b over 2a. This helps you find the x in your vertex. To find the y, you plug in x. For our vertex form formula is y equals a times x minus h squared plus k. So change the sign of what you're plugging in, your h, what you're plugging into the parentheses. K does not change the sign. So these are also, this one especially, make sure you know, yes. Yes. Yeah, so this is technically your h, and this would be your k. So let's find it. This is our a, b, and c. So it would be negative 12 over 2 times 1. So that would give us negative 6. So the h is going to be negative 6. Then to find our k, we would plug in negative 6 into our function. We'd find f of negative 6. So that would be negative 6 squared plus 12 times negative 6 plus 33. So 36 minus 72 plus 33. Negative 36 plus 33 would be negative 3. So negative 3 is our k. So when we plug it in, we'd have y equals, what's our a? A is the same thing from your standard form here. So a would just be 1. So times x minus negative 6 would be plus 6. We flip the sign. And then minus 3. So this would be our vertex form. Where our vertex would be negative 6, negative 3. So to describe the end behavior of our graph, we look at the highest degree term. If it's an even exponent, it's going to have the shape of a parabola. So their end behavior is going to go in the same direction. If it's positive, they're both going to go up. So this would be rises left and rises right. If they were odd, they'd go in opposite directions. So if it was like an x cubed graph, it'd look like an x cubed graph with our end behavior. So any odd exponent would have this end behavior. If it's a negative x cubed graph, it would go in the opposite direction. So the overall slope of it would be decreasing. Next question talks about multiplicity. So that's how many of that answer we have. So solve, find your zeros. Here when you set it equal to 0, we get x equals plus or minus 5. We've got one of each of them. I can't remember how the midterm words it exactly, but it would be specific. On WebAssign, it says that there's a multiplicity of 1. It may say that there's no multiplicity because it doesn't repeat, but that's the same thing. If we had, hypothetically, x equals, let's say, 2, 2, and 5, we would have a multiplicity of 2 at 2. So multiplicity is just how many of that answer you have. Yeah, if your multiplicity is even, it would touch and turn. So at 2, we would touch and turn. So it bounces off of the x-axis. If your multiplicity is odd, so at 5, it would go through, here we'd say, depending on what your function is, but it would go through the x-axis. 5 meaning that there's only, or odd meaning that there's only one of them. We have a multiplicity of 1. So it doesn't matter what the value of the number is, it's how many of that number you have. 27 is a good one to solve. So x to the 4th power minus x cubed minus 12x squared. How would we solve this? How would we find the zeros? Awesome, we can take out an x squared. We're left with x squared minus x minus 12. Here we can just factor. 2 factors of negative 12 that add to negative 1, negative 4 and 3. So x minus 4 and x plus 3. So we get x equals 4, x equals negative 3, and we'd set this equal to 0. So x equals 0 and 0. And at 0, we'd have a multiplicity of 2. (28) says solve using long division. On the test, just pick the right answer choice. You don't have to solve it exactly like the directions say, but the question on the test, I think, is something that you have to use long division for. So if you had a divisor that was like x squared plus x plus 5, something like this, you can't use synthetic division. If it was just a binomial like x minus 5, you could use synthetic division. I don't care, just find the right answer. But if you had a polynomial or a trinomial, you'd have to use long division. Do you want to practice long division with the x minus 5 or with something longer like the x squared? We'll use the longer one, okay. So x squared plus x plus 5 is going to go on the outside. And then inside, we have x cubed minus 6x squared minus 15x plus 25. Remember, if you are missing any term inside the box, make sure you put a 0 in that spot. Like if I didn't have an x squared, I'd want to put a 0x squared in that spot. So inside the box, you need every term as a placeholder. But here we have to the 3rd power, 2nd power, 1st power, and our constant, so we're good. So for long division, we start by dividing. X cubed divided by x squared would be x. Then we multiply. So x times everything out front, we get x cubed plus x squared plus 5x. Change the signs and combine. So our 3 steps for long division are divide. 2 would be multiply. And then 3 are change the signs and combine. So our first terms cancel. This would be minus 7x squared minus 20x. Then we repeat. We do it again. So negative 7x squared divided by x squared would be negative 7. Multiply that with everything out front. We get negative 7x squared minus 7x minus 35. Change the signs and combine. So plus, plus, plus. These cancel. Negative 20x plus 7x would be negative 13x. And this would be 60. Now we can't take away an x squared from the negative 13x. Once you hit your constant, everything after that is your remainder. So our remainder would be, we can say plus negative 13x plus 60 over our divisor, which is x squared plus x plus 5. So that would be our answer. So if it was asking us to divide by x minus 5, positive 5 would go on the outside. The coefficients would go on the inside. So 1, negative 6, negative 15, and 25. It's obviously going to give you a different answer than what we just did because we divided by something different. But we'll practice the next one using synthetic division.
Is there a way to check on?
Let's do synthetic division with 29. So outside the box, we're going to put negative 7. Inside the box, we'd do 5, 38, 19. Of course, this one has huge numbers. Synthetic division, we drop down the 5. Multiply, we get negative 35. Add 3, multiply, negative 21. Add, okay, it works out to small numbers. Negative 2, positive 14. Our remainder is 0. So then our answer, since we started with x to the third power, our answer is going to start with x to the second, so 1 less. X to the second plus 3x minus 2 with no remainder. Yes.
What was the, like?
But if we had a polynomial, let's say like x to the fourth power plus 3x cubed minus 2x plus 100, something like this. Actually, let's make it plus 10. This we can't factor. Bless you. So if you can't factor, you can use last over first. So factors of our last over factors of the first coefficient. So factors of our last would be plus or minus 1, 2, 5, and 10 over factors of 1. And then you can use synthetic division. Whatever gives you a remainder of 0 is a factor or is a 0 of your polynomial. So if something doesn't factor, you can use last over first.
But we don't know that.
You should know this.
Wait, so what would it be asking for?
It'd be asking for the zeros, find the zeros, or the solutions here. So inside the box, we'd put 1, 3. We're missing an x squared. So 0, negative 2, and 10. I doubt that this works out because I made up the numbers. But you would try any one of these values. So we could try positive 1, negative 1, positive 2, negative 2. Use synthetic division. Whatever gives you 0 would be a factor of your polynomial.
Wait, how'd you get the numbers on the top for last?
The factors of our last term. So what multiplies and gives you 10.
Okay.
30, 31, imaginary numbers. You guys should know this. Just combine your like terms. Put the real parts together. So this would be 10. Imaginary parts go together. This would be plus 6i. You don't have to stress about keeping it in standard form because it's multiple choice. For something like 31, where we have to simplify first, you guys know how to break down a radical. A negative under your square root would turn into an I. So this would give you an I. Then you would combine your like terms. You guys can do these. Yes. For something like 32, make sure you know that if it's squared, write it twice and FOIL it out. You cannot distribute the squared. What does I squared turn into? -1. Yes.
Are we gonna have a question with like the I to the 435th power or something?
I don't think so.
Wait, what are the rules of the I again? So I squared is 1.
I cubed is -1.
I to the power of 0, like for the rules, if we had a really big one, we divide. I to the power of 0 would be 1. I to the first power is I. I squared is -1. And I cubed would be -I. I mean, the first three are like kind of common sense. Like those are easy. You can figure out because anything to the power of 0 is 1. I to the first power is I. I squared, you know, should be -1. So then I cubed, I mean, you could either write it out and figure it out, but it's going to be the one that you're missing, which would be -I. And then, so if you divide, if we had, let's say, I don't think that there's one on the midterm, but just to practice, I to the power of 201. We would divide it by 4. Whatever your remainder is, you would look at which one of these. So if we divided 201 by 4, we would have a remainder of 1. So that would be just I.
Why are we dividing by 4?
That's just the rule. For 33, we'd FOIL. 34, we'd simplify first, and then you can combine the square roots together.
Can you do 33?
Yeah. Let's do 33. So when we FOIL, we'd get 45. And then -5 square root -10. I'll leave it like this and then simplify. Then +9 square root -5. And then here, this would be, I'm just gonna leave it, it's negative. I'll leave it separated for now. -5 times square root of -10. So when we simplify, we want to take the negatives out and turn them into i's first. We can't simplify square root 10 or square root 5. It doesn't break down anymore. But when we multiply them together, here we would have -I squared. We can multiply the square roots together, so we'd get square root 50. This can break down more, so square root 50 would be 25 times 2, and 25 would be 5 times 5. So 5 would come out, so -5I squared square root 2. What does I squared change to? -1, so that would make this a +5. Yeah, go ahead. There's a fly. All right, so we got rid of that. We turned it into +5. Everything else we can't combine, so it would be 45. Let me write it down here. 45 minus 5I square root 10 plus 9I square root 5. These are, even though they both have an I, they're not like terms because the square roots are different, so you can't combine them. And then plus 5 square root 2. 33. Something like 36. We want to write the quotient in standard form. So if we had like a binomial on the bottom, if it was like 5 plus 2i, you'd want to multiply by the conjugate of the denominator. Here it's just 2i, so we can just multiply by 2i. Our goal is to get rid of the I from the denominator. So, or actually, we could have just separated them and divided it, but it's fine. We'll do it this way. We can distribute up top. We get 16i plus 20i squared over 4i squared. I squared changes to be what? negative 1, so that would be negative 4, and then we can change this to be negative 20. So we can simplify it and split it up, or just divide them all by negative 4 if you wanted to. Everything divides by negative 4. So 16 divided by negative 4 would be negative 4i, and then negative 20 divided by negative 4 would be plus 5. In standard form, the real part has to come first, so 5 minus 4i. A good one to practice for these, if let's say we had 1 plus 2i over 5 minus 3i, something like this. You'd want to multiply by the conjugate of the denominator, so 5 plus 3i on the top and the bottom. Yes?
For questions like these, would we never have a variable?
I is kind of like your variable here, but you wouldn't have like an x thrown in there. 37. First, we can start by taking out the x. We're left with x cubed minus 7x minus 6. So we know that one of our zeros is going to be 0 because we took out that x. X cubed minus 7x minus 6 doesn't factor, so we could use our last over first. So factors of the last over factors of the first. Factors of negative 6 would be plus or minus 1, 2, 3, and 6. Over factors of our first are just plus or minus 1. Inside the box, we'd put our coefficients. We're missing an x squared, so I'd have to put a 0 in that spot. So we have 1, 0, negative 7, negative 6. We could try any one of our possibilities here. Let's try 1. We'll drop down the 1, multiply, we get negative 6. This would be negative 6. Doesn't work. We're looking for 0 as our remainder. So we got to try something else. Let's try negative 1. So negative 1, multiply would be positive 1, negative 8. That doesn't work either. Did anybody try anything that works here? I know you guys have different numbers, but negative 3? Let's try 2. 1, 2. This would be 2, 4, negative 3, negative 6. Doesn't work. Are my signs right? Yeah. We can try negative 2.
Wait, I'm confused, because why does negative 1 work if it says at the bottom of the answers the zeros are 0, 1, and negative 2?
Maybe my math went wrong. Let's try negative 1 again. Oh, yeah, my math did go wrong. 1, this would be negative 1. When I multiplied, I didn't change the sign. So this would be positive 1. This is negative 6, positive 6. Thank you. I would have sat here all day trying to find that. So negative 1 does work because we get 0 as the remainder. So we can add that to our list of zeros. We started with x to the third power. So this would be x to the second power. Once you get x to the second power, you can just factor it. So this would be x squared minus x minus 6. You could do last over first again, but it'd be easier just to factor. So 2 factors of negative 6 would be negative 3 and 2. So x minus 3, x plus 2, x equals 3, and x equals negative 2. So we'd add those to our list. This is one of those questions where you can use your answer choices to help you. If all of your answer choices had, let's say, negative 1 in it, then you kind of know that negative 1 is going to work. So do that, make it smaller, see if you can factor it from there. So use your answer choices to help you. Questions here? For something like 39, we find the domain Domain, we know that our denominator cannot be equal to 0, so set the denominator not equal to 0. To find any vertical and horizontal asymptotes, our vertical asymptotes is the same as the domain. We'd set the denominator just equal to 0. So vertical asymptote, set the denominator equal to 0. Horizontal asymptotes, we look at the degree of our numerator and denominator. When they're the same degree, we look at the coefficients. So our horizontal asymptote here would be y equals 7, because it'd be 7 over 1. If, let's say, I'll do it on the side over here. Let's say we had x cubed over x squared. When your degree on the top is higher than the degree on the bottom, our horizontal asymptote would be none. We don't have any. If our degree on top is higher than the degree, or lower than the degree on the bottom, so let's say we had x over x squared. Our horizontal asymptote here would be y equals 0. So if they're the same, look at the coefficients. If the top is greater, then you have no horizontal asymptote. If the bottom's greater, your horizontal asymptote would be y equals 0. Yes?
How did you get the horizontal numbers again? Because when I started to do it, x squared equals -1.
So when we solve, subtract 1, x squared equals -1. What do you get when you take the square root of -1? Imaginary. So that's why it's all real numbers, because there is no real number that we can have in our x that would give us 0 in the denominator.
So anytime you get anything like imaginary, it'd be all real numbers or something?
Yeah, it's kind of similar to what we did in the last section with like our critical numbers. We can't have critical numbers that are imaginary. So like if this question asks for, let's say this was our derivative and it asks for critical numbers. When you set the denominator equal to 0, it only gives you imaginary numbers, so you wouldn't have any. You wouldn't have any that give you undefined. You'd set the top equal to 0 also, if any others.
So with the vertical asymptote is 1.
Vertical asymptote, yeah, because there is no real number when you set the denominator equal to 0. For number 40, it says find the zeros. How would we find the zeros? First, let's factor our numerator. Hello. So our numerator factors into x plus 5, x minus 5 over x plus 5. So those would cancel because we have a whole. So our only 0 would be x equals 5. It's not -5 also, because -5 would give us undefined here. If you had a question like this, where it asks you to graph, again, you could plug it into your calculator if you're not sure, or do what we did in the last question. You can find your asymptotes, find your horizontal asymptote, your vertical asymptote, find your zeros, plug that on the graph. So it's multiple choice. Use the answers to help you. Just process of elimination with your graphs. Yes? So to find your x-intercepts, plug in 0 into the y. Here we don't have any x-intercepts. To find the y-intercepts, plug in 0 into the x's. So our y-intercept would be, I'll talk about that in a second. Y-intercept would be our x is 0, y is 1 over 7. So even just by knowing this, it helps you figure out which one's your graph. For the asymptotes, our vertical asymptote we set the denominator equal to 0. So we have a vertical asymptote at x equals 7. This, again, probably eliminates some of your answer choices. And then the horizontal asymptotes, we look at the degrees. Our degree in the denominator is greater, so our horizontal asymptote would be y equals 0. Yes.
So for answer choices, we use like different graphs.
Yeah.
Okay.
Yeah, you're not going to have to graph anything because it's all multiple choice, but you might have a question that has graphs as your answer. Like it'll say graph, but you'll have 4 or 5 graphs to choose from.
And would there be like labeling questions or no? Because it's
Horizontal, we look at the degree. So our degree of our numerator, we don't have an x, so the degree is technically 0. Degree of our denominator would be 1. So when the denominator is greater, it's y equals 0. So if the numerator is greater, let's say we had x cubed over x squared, this would be none for horizontal asymptote. If they're the same, let's say we had 2x squared over 5x squared. If the degrees are the same, we look at the coefficient. So this would be y equals 2 over 5. If the denominator is greater, let's say we had x over x cubed, this would be y equals 0. One way that I kind of remember it is we know that if the numerator is greater by 1 degree, you can divide to find the slant asymptote. So if there's a slant asymptote, you have no horizontal asymptote. That's what I have to refer back to remember these. But any questions? Perfect. For something like 43, factor the numerator and the denominator. Make sure you don't have any holes, because remember, you can't have a vertical asymptote if you have a hole in that spot. This one, you don't have any holes. But just in case if you had something like this that factors, factor it first. Factoring will help you solve for everything else. So you guys can have your graphing calculator. So for some questions like this, we plugged it into our graphing calculator. So if it says find the limit as x approaches 1, we'd want to plug in numbers that approach 1 from the left and from the right and see what value we get closer and closer to. We also figured out how to do this without a calculator, but refer back to your calculator if you need to, or even just like graph this and see what y value does your graph approach as x gets closer to 1. If you ended up getting 0.16 and 0.16 and your answer choices were fractions, turn your fractions into decimals to figure out what matches.
Can you go over how to
For this question,
Yeah.
so this one, we can plug in 1 because it doesn't give us 0 in the denominator. So first thing you always want to try is direct substitution. Can you plug it in? If it's undefined, then you'll have to try something else. But for this, when we plug in 1, we get -1 on top over 1 plus 3 minus 10, so -6, which would be 1 over 6. So always, first thing you want to try with limits, direct substitution. Yeah. For the next one, 45, we want to find the limit as x approaches -1 of our function here. So limit as x approaches -1. So -1, we can use our graph to help us here. It's the y value as our x approaches the left and the right. So our x is -1 as our graph approaches the left and the right. Our graph approaches 0. So even though it exists down here at -2, we're talking about the graph as a whole. What does our graph look like? What value do we approach from the left and the right? So here our limit would be 0. For something like this, we've talked about what the graph looks like. But again, just put it in your calculator, make it graph it for you, and then see what value does your graph approach from the left and from the right. Here, we approach two different values, so what would our limit be? The limit does not exist. For 47, we can't use direct substitution. If we plugged in 6, we'd get 0 in the denominator. You know that we have an asymptote at 6. We talked about this graph too. If you have something like 1 over x, our graph is going to look like this. Here it just shifts a little bit. But because we approach two different values, our limit here does not exist.
So every time we see something like 1 over x, it's going to be
Yes, but also remember if we had, let's say, 1 over x squared, here our graph would look like this. So our limit would be infinity here. This one does not exist because they approach two different numbers. The second one, our graph goes to the same value, so it'd be infinity. Since they both go up at 0. If this was the limit as x approaches 0. So for these types of graphs, or these types of limits, it helps to know the graph. So if you get to a limit question, direct substitution doesn't work, plug it into your calculator. Look at the graph in your calculator and see, are you approaching the same value or are you approaching different values? I mean, we had to, for the tests for this, know what the graphs look like. So now use your calculator to help you if you don't remember. Let's say for this question that it asked for our limit as x approaches infinity. What would our limit be as x approaches infinity? 0. Awesome. As x goes to infinity here, our graph, our y value is getting closer and closer to 0. So our limit would be 0. What about our limit as x approaches negative infinity? It would also be 0. As we go to negative infinity, our graph gets closer and closer to 0. So you will have some limits as x approaches infinity. Those are just going to be like your horizontal asymptotes. But plug it into the graph, use the graph to help you. For 48, direct substitution, just plug it in. 12, same thing, direct substitution, just plug it in. That's always the first thing you should try with limits. Can I just plug it in? If you get 0 in your denominator, then you can't plug it in. If you plug it in and it gives you undefined, it doesn't work. So typically if it's not a fraction or if it doesn't give you something undefined, direct substitution is going to work. So for like this, we have a fraction, direct substitution would not work. Well, if the limit was 0, the limit as x approaches 0. But if it was just a regular polynomial, use direct substitution. So for this question, limit as x approaches 0, simplify your graph. So when we simplify, we get x minus 1, because we can divide them both by x. When you simplify, now you're just finding your limit of this. So if you have a whole, simplify, get rid of it, and then just find the limit of your simplified version. It'll give you the same value for your limit. So for here, it's asking for the limit as x approaches 0. So it's really just the limit as x approaches 0 of x minus 1. So when we plug in 0, we would get negative 1. For 51, we can simplify this also. All three of our terms are divisible by x. We get 1 over x plus 3. Once we simplify it, direct substitution works. Just plug in 0. You'd get 1/3.
I had a question for if there's like a graph.
So for 52, factor it, simplify, then plug it in. Same thing with 53. It didn't put the question in it, but looking at the solution down here. It factors cancel out the whole. Once you cancel out the whole, then you can use direct substitution. Same thing with 54. Factor it, cancel out the whole, plug it in. So to find the x values at which f is not continuous, you're looking to see where you have a whole or where it's undefined. If you have a whole, that would be removable. If you have an asymptote, that would be non-removable. But if we had something like x minus 5 and we factored our denominator and we got x minus 5 times x plus 2, we'd have a whole at x minus 5. So we'd have a whole at x equals 5. And then we'd have an asymptote at x equals negative 2. So this would be removable, this would be non-removable. So it's possible to have both in the same question, but not at the same spot. It helps to know what your graph looks like. So here we have a vertical asymptote at x equals 5. Because it's 1 over x, our graph is going to look like this. So the limit as x approaches 5 would not exist because they approach two different values. But the limit as x approaches 5 from the negative direction, so we're coming from the left, our graph goes down to negative infinity. The limit as x approaches 5 from the positive direction, so we're coming from the right, our graph is going up as we go from the right, would be positive infinity. This one, same idea. We have an asymptote at x equals 1. But because it's x squared, our graph's going to look like this. So as we approach from the left and from the right, they both go up to infinity. So if it just asks us for the limit as x approaches 1 without specifying the direction here, it would be infinity also, because they approach the same thing from the left and from the right. We know we have a vertical asymptote at x equals negative 3. So our graph would look like this. So from the left, we're going down to infinity from the right. So if it was as x approaches negative 3 from the positive direction, it's talking about the right. So this goes up to infinity, so it'd be infinity. For 62, it factors. So the top would be x plus 3, x minus 3 over x plus 3. So we have a whole because they cancel. So that would be why it's removable discontinuity, because this is a whole. For 63, this is one of those where we can graph. We have a vertical asymptote at 7. However, the negative on top flips it. If you had a negative out top or a negative out front or a negative on the bottom, it would flip it. So instead of both going up to infinity, they now both go down to negative infinity. Because it's x squared, they're going to go in the same direction. So the limit as x approaches 7 from the negative direction would mean that it's coming from the left. This would be negative infinity. If this said limit as x approaches 7 from the positive direction, it would also be negative infinity. For 65, we had a question similar to this on the test and quiz for this section. You can plug them, or you can separate it and treat the limit as two different things. So we can do the limit as x approaches 0 from the negative direction of 7 plus the limit as x approaches 0 from the negative direction of 3 over x. What's the limit as x approaches 0 of 7? 7. Now here the limit as x approaches 0 from the negative direction. We need to know what our graph looks like. So this is one of those where it boomerangs like this. So from the negative direction, what would our limit be? Negative infinity, perfect. So this would be 7 plus negative infinity or minus infinity. So that would just be negative infinity. Questions? Same thing with 66. Split it up. The limit as x approaches 0 from the negative direction of x squared minus, you can do minus on the outside or keep it on the inside. It doesn't matter. Just make sure you're aware of that negative. So as x approaches 0 from the negative direction of 6 over x. If we plug in 0 to our first limit, to the x squared, what would we get? 0. Here, we know that our graph looks like this. So as x approaches 0 from the negative direction, what would our limit be? Negative infinity. So it would be minus negative infinity. What's 0 minus negative infinity? Positive infinity. So if you've got multiple things going on, you can split it up and find the limit separately. Any questions here? So if you said plus the limit as x approaches 0 from the negative direction of negative 6 over x, it would flip your graph. So just make sure you remember to flip it. So from the negative direction, our x now goes to positive infinity. For 68, it says find the derivative by the limit process. Yeah. You can find the derivative however you want. So remember we talked about this formula. If it gives you this, and you want to plug in the x plus delta x, that's fine. But now we know the shortcut to find the limit. So you don't have to do that. So I would recommend not doing that. Save yourself the time and effort. Find your derivative. We get 2x plus 1. If you do the limit process here, you'd end up with the same thing. Let's just find the derivative. For 69, you can use your quotient rule if you want. Or if you wanted to, we can take our coefficient out, 5 over 2, and then we can move this to the top by changing the exponent to negative, so times x to the power of negative 9. You'll get the same answer. If you're more comfortable doing the quotient rule, just do the quotient rule. It'll work out to be the same thing. Here we would get negative 45 over 2 times x to the power of negative 10. So then don't forget to move it back to the bottom, but your answer choices would be with it on the bottom anyways. So it'd be negative 45 over 2 times x to the 10th power. '70 says find the slope of the graph of the function at the given point. Use the derivative feature. We're just going to find the derivative to find our slope. So to find the slope of the graph at the given point, we want to find the derivative. So here we have to use our chain rule. So we find the derivative of the outside. This would be 6. The inside stays the same, 7 minus x to the power of 1 now. Then we have to multiply it times the derivative of the inside. Don't forget to multiply it times the derivative of the inside. Derivative of our inside would be negative 1. So we get negative 6 times 7 minus x. If you want to simplify it, you can. You can distribute. if you want. When we find the slope of the graph of the function at the given point, we're plugging in our x value into the derivative. So this would be -6 times 7 minus 1. So -6 times 6 would be -36. This is our slope. On WebAssign, what they did is they FOILed this out. So they FOILed 7 minus x times 7 minus x and then distributed the 3 and then took the derivative of this. You'd get the same thing.
So when you use the numerator,
You don't. Here you don't. If it asked for the equation of the line, of the equation of the tangent line, that we would need to use the 108. So we would have y minus y1 is equal to m times x minus x1. This would be our x1 and y1, and this is our m. So y minus 108 is equal to -36 times x minus 1. So that would be when you use the y. But if you're just finding the slope, you don't use it. Find the derivative here. You can find the derivative of this and then find the derivative of this. You can use the quotient rule if you want for the second part. I would personally rather move it to the top. So this would be t squared minus 9 times t to the power of -3. Then we can take the derivative. So we get 2t plus 27t to the power of -4. And then we can move it back to the bottom. So 2t plus 27 over, since it's just the t that has the power of -4, it's just that gets moved to the bottom of this part of it, not the whole thing. So t to the power of 4. So this would be our derivative. This is our, for 72, you can find your derivative using the quotient rule, or you can see that it simplifies, so simplify it first. This would be 3x squared plus 7x. Then find the derivative. It'll save you some time and effort. So 6x plus 7. '73, we're going to use the product rule. So the first times the derivative of the second plus the second times the derivative of the first. So 3x plus 2. The derivative of the second would be 3x squared plus the second times the derivative of the first, which would be 3. We would distribute and then combine your like terms. All right, quotient rule. Low D high minus high D low over low squared. You want me to work it out?
no.
We're good with this? Okay. So find the derivative of our function and then find f prime of c. Just find the derivative and then plug 6 in to find f prime of c. Plug it into your derivative. What would we have to do to find the derivative here? Quotient rule. So then once you take the derivative, you're plugging 6 into your x's. Again here, quotient rule. Quotient rule. Let's practice this one. So low D high, low would be square root x. I'm actually going to change it to be x to the 1/2 power. Look at your answer choices, see what your answer choices look like if it keeps the square root. But I'm going to have to take the derivative of it anyways, so I'll just change it to x to the 1/2 power now. So low D high, low would be x to the 1/2 power times the derivative of our numerator, which would just be 4, minus high, 4x minus 7, times the derivative of our denominator, which would be 1/2 x to the power of negative 1/2 over
After you're working at the quotient rule?
quotient rule, yeah. Over low squared. Square root of x squared is what? X. How lovely. So 4x to the 1/2 power. Here, we'd have to distribute. Not as lovely. We can I would simplify this first. Make it 1 over 2x to the 1/2 power. So then when we distribute that, and I'm going to distribute the negative, we get minus 4x over 2x to the 1/2 power plus 7 over 2x to the 1/2 power over x. I can combine these together. How? Subtract the exponents. Perfect. So this would be x to the first power minus 1/2. So 4x to the 1/2 power. 1 minus 1/2 would be 1/2. So this would be minus 4x to the 1/2 power. Just kidding. Then when we divide it by 2, it should be 2. And then here, I'm going to move it to the top also just to make it a little bit easier. This would be 7/2 x to the power of negative 1/2. We can combine our like terms, and then when we divide everything by x, I'll work it out. 2x to the 1/2 plus 7/2 x to the negative 1/2 over x. We can combine these together. If you want to call it over x and over x. Do the same thing. Subtract the exponents. Each step of the way that I'm simplifying, I would be looking at the answer choices, see how simplified our answer choices are. It might even just leave it, it wouldn't leave it like this, but for any other question, it might leave it where you don't have to distribute, you don't have to FOIL. So look at your answer choices. So I would change this to be negative 4. I'm going to call it x because I don't like the way that t's look. X plus 4 to the power of negative 4. Then do the chain rule. So I just moved this to the top, made my exponent negative. So I didn't have to do quotient rule. So when we do chain rule, we would get 16 times x plus 4 to the power of negative 5. Then multiply it times the derivative of the inside. What's the derivative of the inside? 1. Don't forget, when you do the chain rule, multiply it by the derivative of the inside. On the last test that we had, a lot of people forgot that with the chain rule. So we'd get 16 over x plus 4 to the 5th power. When it asks for find dy over dx, when we take the derivative of y, we need to make sure we include the dy over dx. Now from here, we would solve for dy over dx. We just want that all by itself, so I just need to move everything else to the other side. So subtract 9x to the 8th power. So 4y cubed dy over dx is equal to negative 9x to the 8th power. Then we would divide by 4y cubed. Be careful with the math here. This part should be easy, but on the test, when this was on the test, a lot of people would subtract both of them to the other side, just like the algebra went wrong in this step. So just be careful. dy over dx is equal to negative 9x to the 8th power over 4y cubed. Same thing here. Whenever we take the derivative of y, make sure you include the dy over dx. For this part, you have to use the product rule. That's where a lot of people went wrong on these types of questions on the test 2, I think it was. So our first would be, you can call it 6x times y. do your first times the derivative of the second plus the second times the derivative of the first. So you have to use the product rule for that. Do you want to see this one worked out, or we're good here? Work it out? Yeah. So 3x squared plus 3y squared dy over dx is equal to, our product rule would be the first times the derivative of the second. 6x is our first. The derivative of the second would be dy over dx. Plus the second, so it'd be y, times the derivative of the first, which would be 6. And then the derivative of -1 would just be 0. So once we find the derivative, we want to get our dy over dx's to one side and everything else to the other. So I'm going to subtract 6x dy over dx to move it to the other side. And subtract 3x squared to move it to this side. Again, be careful with the math here. You're just rearranging. It just looks a lot more complicated than a normal equation, but you guys know how to move things around in an equation. Minus 6x dy over dx is equal to 6y minus 3x squared. On the left side, we're going to take out our common factor, which is dy over dx. We're left with 3y squared minus 6x is equal to 6y minus 3x squared. And then last step is we're just going to divide this to the other side. So dy over dx is equal to 6y minus 3x squared over 3y squared minus 6x. The second part of this question says to evaluate the derivative at the given point. We'd plug in 3 into the x and 2 into the y and simplify. For the related rates question, practice the triangle one from the last test. It's going to be a ladder, so just practice the one from the test. For 86, when we find the derivative here, you have to use the product rule. For these questions, since we're differentiating it with respect to time, we need to put the dx over dt and dy over dt. So the first would be x times the derivative of the second would be dy over dx. dy over dt. Plus the second, so y, times the derivative of the first would be dx over dt, is equal to the derivative of 8 would be 0. So for the first question, it says find dy over dt given x equals 2 and dx over dt is 15. So we can plug that in. X would be 2. We're looking for dy over dt. Don't know what that is yet. Dx over dt is 15, 15. How do we find what y is? So it gives us an equation here, and we can plug in that x is equal to 2 and solve for y. So we have 2y is equal to 8, divide by 2, y equals 4. So use your equation to find your y if it doesn't give it to you. So 2 dy over dt, 4 times 15 would be 60. When I move it to the other side, it'd be negative 60. And then divide by 2. dy over dt is negative 30. B is a similar equation. It just gives you different values and it asks for dx over dt. But you'd have to plug in your x to find your new y. It's kind of like a whole separate question. Questions? All right, the new stuff. 87, find the critical numbers of the function. So to find the critical numbers, we want to find the derivative, set it equal to 0, and Find where it does not exist, or where it's undefined. So we find our derivative here. We got 4x cubed minus 24x squared. We'd set this equal to 0. So let's do that first. When we set it equal to 0, how would we solve? Take out the x squared. Perfect. We're left with, we can take out the 4x. That works even better. We're left with x minus 6. So we have x equals 0 and x equals 6. The second part is we have to find where this does not exist. Is there anywhere where 4x cubed minus 24x squared would be undefined or where it does not exist? No. So we would only really need to check where it does not exist if you have a fraction. Set your denominator equal to 0 to find where it does not exist. We'd add those to our critical numbers. So here we just have 2 critical numbers. For 88, similar, we want to find our critical numbers. We end at 10, right? Okay, 15 minutes. Time flies when you're having fun. Find our critical numbers. So find our derivative. What would our derivative be here? -1. Our critical numbers, we'd set it equal to 0 and find where it does not exist or where it's undefined. Is there any value, any x value, that would make this equal 0? No. So do we have any critical numbers? No. So we only need to check the endpoints. So -4 and +4. So plug them both in. We'll do it. We get 11 and 3. So because this is our smaller number, this would be our minimum. So our minimum would be 3, 4. Because this is our larger value, this would be our maximum. So our maximum would be -4. I did that backwards. This should be 4, 3. And -4, 11 would be our maximum. So let's say our question was 1 over x plus 3 on the interval from -5 to 5. Like this is what you're asking? So we know that x cannot equal -3. Since -3 is in the interval, this would be not continuous. But if our interval was from 0 to 5, it would be continuous on that interval. So let's say this was our derivative. We found the derivative and we ended up with whatever over, we'll use the same thing. So x plus 3 squared. We know that x cannot equal -3 still, but we are checking to see if it's differentiable on the open interval. So if our open interval was from -3 to 5, this is differentiable on this interval. It wouldn't be continuous on the interval because it would be a bracket, but it is differentiable because it's not including -3 in our parentheses.
Is it only
Same idea with the square root. If we had, like if our function was the square root of x plus 2, we know that x has to be greater than or equal to -2. So depending on what our interval was, it couldn't be anything less than -2. So if our interval was from 0, well, this would be greater than 0 to 5, we're good. But if our interval was from -5 to +5, this is not continuous. It doesn't exist on here. Thinking about how to calculate your grade, you could take your quarter 1 grade, so quarter 1, multiply it by 0.4, quarter 2, multiply it by 0.4, and then the midterm, multiply that times 0.2. Add up these 3 values, and that would give you your final grade.
wait, the quarter one test grades or just like what you?
Determine whether Rolle's theorem can be applied to f on the closed interval. So to see if Rolle's theorem can be applied, we need to check three things. We need to see, is it continuous? Is it differentiable? And does f of A equal f of B? So check these three things. So once we know that all three things are true, to find our value of C, we would find the derivative. So f prime of x would be negative 2x plus 6. Set this equal to 0 and solve for x. So this is Rolle's theorem. Do you want to see it worked out? We're good from here. Okay. Mean value theorem. We would have to check to see if it's continuous, if it's differentiable. When these two things are true, we're going to use this formula to find the slope. We'll do it. F of B would be 4. So this would give us 16. F of negative 3 would give us 9. So 16 minus 9 over 4 minus negative 3 would be 7 over 7. So that's 1. So then we're going to take the slope and set that equal to our derivative. So our derivative is 2x. We set it equal to 1. So the difference between Rolle's theorem, we always set it equal to 0. Mean value theorem, you have to find the slope and then set your derivative equal to that. So x would be 1/2.